Hey, hi everybody. We're going to move into section 8.4 of chapter 8. Keep in mind, everything in chapter 8 is dealing with quadratic equations. Everything quadratic. And in 8.4, we're going to be looking at equations that are able to be written as quadratic equations. They're equations actually written in a form to where by using an appropriate substitution we can create a quadratic equation. And so we're going to go to the board and we're going to show you some ingredients of equations that are quadratic in form. When we're looking at the equation for number 1, it is not a quadratic equation, it's simply a polynomial equation. But this happens to be an equation that is quadratic in form, meaning we can transform this equation into a quadratic equation using an appropriate substitution. Now let me give you a few of the ingredients of what does it take for an equation that is quadratic in form to actually, through a substitution, become a quadratic equation. First characteristic, the polynomial that is on the left-hand side must be a trinomial. Secondly, the last term of the trinomial must be a constant term. The last term cannot be a variable term. It has to be a constant term. And then the most critical characteristic is this. The variable factor of the first term, in this case the x to the fourth, the variable factor of the first term is equivalent to the square of the variable factor of the middle term. Let me just run that statement by you again. Third characteristic, the variable factor of the first term must be equivalent to the square of the variable factor of the middle term. If we take the variable factor of the middle term, x to the second, and square it, x to the second squared gives us the first term. And when we have that kind of a characteristic, then we will be looking at an equation that is quadratic in form and is able to be transformed to a quadratic equation using an appropriate substitution. And here's where we get the substitution involved. We're going to pick the variable u. There's no magic in u, but we're going to pick u. And we're going to let u be equal to the variable factor of the middle term. We're going to let u be equal to the variable factor of the middle term. So we're going to let u be equal to x squared. Now, we're going to begin the process of getting this written so that it looks quadratic. We're going to begin off by bringing over this x squared and putting it right below the x to the fourth. We're going to tuck it, and we're going to square it. Now just pause there for a second. X to the second, bullseye. They're equivalent. Bring down the coefficient of -5, make a house, and inside that house, put the x squared. They're the same. Then bring down the +6 and the 0. It's beginning to look a little bit more quadratic, so to speak. Now we're going to substitute. It says u is equal to x squared. So we're going to substitute u wherever we see x squared in this equation. So we see it here, So we'll substitute u in place of that x squared, and we'll have u squared, that squared is him, negative 5u plus 6 is equal to 0. And now we'll take this quadratic equation. Now it's quadratic. And now we're going to solve this quadratic, and we're going to solve it by factoring. All of these that we're going to be doing in this section are going to be able to be solved by factoring. So we make two binomial structures, set it equal to 0. Both binomials have to begin with a u. The sign of the last term is positive, so both binomials will carry the sign of the middle. And this symbol also regards itself as not only a positive, but it reflects addition. Two factors of 6 that when really added would give 5 would be 2 and 3. Now we'll use the zero product property and find out what our values of u are. U minus 2 is equal to 0, or u minus 3 is equal to 0. U is equal to 2, or u is equal to 3. Now let me just pause there for a second and make this mention now that we are down to this point. A mistake that some students will make when solving an equation that's quadratic in form, when they get their answers for what u are equal to or what u is equal to, they will believe that those are the solutions and they'll stop the process. They are not the solutions. They are the values of u, but they are not the values of x that we need. So once we find the values of u, then we're going to come back to this expression, u is equal to x squared, and we're going to substitute now the x squared in place of our u. So in place of u, we'll write x squared is equal to 2, and over here we'll write x squared is equal to 3. And now we will solve both of those quadratic equations, and then we'll have our solutions. Now, this is a quadratic that is already set up to use the square root method. Both of them are. So we'll find the square root of x squared, which is x, and that will be equal to positive or negative the radical of 2. He can't be simplified any further. So there's 2 of our solutions. Or square root of the left, x is equal to positive or negative the radical of 3, and that can't be simplified anymore. If you want to come down and then put a finishing touch on it, we'll put it in roster notation, positive or negative root 2, comma, positive or negative root 3, and we put him to bed, and he is done. Now, one more comment before I erase it. On one like number 1, we could have solved this without a substitution. We could have just gone immediately to 2 binomial factors, and we could have come up with the same answer, but that's not what the theme of this section is. That is why I didn't do that. All right, now we'll go to number 2, and number 2 will certainly look different. They're all going to look different as we go through a few of these problems. Number 2, x minus 2 multiplied by the radical of x minus 8 is equal to 0. Now this is definitely not a quadratic equation, but it is an equation that is quadratic in form because it meets all of the criteria. We have a trinomial. The last term is a constant term, no letters attached to it. And the most critical thing, the variable part of the first term is equivalent to the square of the variable part of the middle term. If you take the radical of x, and square it, you'll get that radicand x, which is m. So this is an equation that's quadratic in form. So we begin by letting u be equal to the variable factor of the middle term. U is equal to, well, I got to back off here for a second. Let's back off. I jumped ahead of myself a little bit. Let's begin right back over here. We have to restate this middle term so that it has an exponent in its appearance. There is no exponent here. There is one here, and we'll put him in here in a moment, but this one is going to have to be restated using a rational exponent. The radical of x will become x to the 1/2. So I ran it a little bit too fast, so let's slow it down. Bring down that x, and let's show that it's being taken to the first. Bring down that -2. Bring that radicand down, and its exponent will become 1/2. Then -8 is equal to 0. Now it's still true. If you take the variable part of this middle term, x to the 1/2, and square it, you're going to get x to the 1, or simply x. So now we'll go to u. U will be equal to the variable factor of the middle term. U will be equal to x to the 1/2. And now we're going to move into getting this to become quadratic. We're going to begin off by bringing over that x to the 1/2, tuck it, and we're going to take it to the second power. Let's just verify that this expression is equivalent to the one above it. If we multiply the exponents here, x to the 1/2 to the second will give us x to the first. Bring down the -2, make a house, place x to the 1/2 in there, then -8 is equal to 0. Now let's substitute u wherever we see x to the 1/2. We see it here, u squared. Negative, we see it here, -2u, -8 is equal to 0. Factor. U plus u minus. The factors of 8 that when really subtracted giving us 2 would have to be 4 and 2, with the 4 carrying the negative and the 2 carrying the positive. U plus 2 is equal to 0, or u minus 4 is equal to 0. U would be equal to -2, or u would be equal to a +4. I'm going to kind of erase some of this top stuff so I can work up above. U is equal to -2, or u is equal to 4. We don't want the values of u, but we needed the values of u so that we could find the values of x. So now we'll return to our substitution statement here, and in place of u, we'll put x to the 1/2. So x to the 1/2 is equal to -2, or x to the 1/2 is equal to 4. Now, what is key about problem number 2 is this. We are looking at an equation that is dealing with a rational exponent. And when you're dealing with rational exponents, they're related to radicals. And so when we come over here, our goal is to find the value of x. To find the value of x, if we square both sides of this equation, we should get x alone on the left-hand side. And we'll do likewise here. But I want to point out something real quick that can maybe help us avoid a little bit of work. I want to come to this one right here. Now keep in mind the denominator of the rational exponent represents the index. So we're looking at square root here and also there. If we were to just change this left-hand side to a radical, I want you to look at this equation. The base of x will become the radicand. And the denominator is the type of root that we have, which is square root. So we would be saying that the radical of x can be equal to a -2. It can't be, because this expression stands for the principal square root or the positive square root of x, meaning the answer cannot be negative. And this answer is negative. So this solution right here, potentially, it's going to have to be rejected. It'll have to be rejected. Now, I'll come back and just to show you why. I'll come back and just erase. And let's just go to this one right here, and let's square both sides, just for the sake of it. Take the left, square it. Take the right, square it. Take the left, square it. Take the right, square it. When we take x to the 1/2 and square it, we'll get x. And the potential answer is 4 for this one. Or, over here, we get x is equal to 16. If we were to substitute both of these numbers, and we need to substitute them into the equation, I'll put that equation right here, x minus 2 root x minus 8 is equal to 0. If we take the supposed answer of 4 and substitute it here, and substitute it here, let's see if it checks. 4 minus 2 root 4 minus 8 is equal to 0. 4, -2 times 2, -8 is equal to 0. 4, -4, -8 is equal to 0. The 4's cancel, then we can see that -8 does not equal 0. So that indicates the solution of x is equal to 4 is not permitted. It's an extraneous solution. People, let me just say it again. It had to be extraneous, because right up here, that denominator indicates square root, and the square root of x cannot equal a negative. So he's gone. Then we test the other potential answer of 16. 16 minus 2 root 16 -8 is equal to 0. 16 -2 times 4 -8 is equal to 0. 16 -8, another -8 is equal to 0. 16 minus 8 is 8, and 8 minus 8 is 0. The only solution. What was critical about number 2? Rational exponents were involved, and when rational exponents are involved, radicals are involved. And if the index that you're dealing with is even, you must check your solutions. You have to. We just found out that one of them was extraneous, the other one was good. Let's go to 3. 2x to the -2nd plus x to the -1st. -1 is equal to 0. Constant term, trinomial. If we take the variable factor of the middle term and square it, x to the -1 to the 2nd. 2 times -1 would give us a -2. It matches this one. This is an equation that's quadratic in form. We're going to come over here to the right-hand side, and we're going to let u be equal to the variable factor of the middle term. We'll let u be equal to x to the negative 1. We're going to bring over this x to the negative 1 and insert it in here so that we can begin our process. Bring down that coefficient of 2, make a house. In the house, put x to the negative first to the second, just to kind of get it into the form of a quadratic. Negative 1 times 2, there he is. Bring down the plus sign, make a house. X to the negative first minus 1 is equal to 0. Now we'll insert u where we see x to the negative first. 2u squared plus u, negative 1 is equal to 0. There is no GCF. It's got to have a couple of binomial factors. I'll just kind of show this a little bit. The middle term is u. A times c is negative 2. If AC is negative, then that means the 9 o'clock and the 3 o'clock areas have to have different signs. One's plus, the other one is minus. 2 times 1 is 2, and 2 minus 1 will give us that u that we need. So it's going to be a positive 2u and a negative 1u. So now let's build it in to our situation. 2u squared plus 2u minus u minus 1 is equal to 0. Let's tuck the front pair, tuck the back pair, slip a little addition sign in there, pull out the GCF of 2u, and that'll leave us with a u plus 1. Pull out a negative 1, and that'll leave us with another u plus 1 is equal to 0. Our binomial factors, u plus 1, 2u minus 1 is equal to 0. U plus 1 is equal to 0, or 2u minus 1 is equal to 0. U will be equal to a negative 1. 2u would be equal to 1. U would be equal to 1 over 2. Let me erase. U is equal to negative 1, or u is equal to 1/2. Now we'll come back and we'll back substitute and replace the u with the x to the negative first. X to the negative first is equal to negative 1, or x to the negative first will be equal to 1/2. To get this to be x, we're going to have to institute the power of a power and multiply it by something so that the result will be x. If we take x to the negative first and take it to the negative first power, negative 1 times negative 1 will give us that x to the positive first. Well, then we have to do it here as well. We've got to take that to the negative first. Over here, we're going to do the same thing. We'll take it to the negative first, and we'll take the right-hand side to the negative first. Now, carefully. X to the negative 1 to the negative 1. We multiply those, we'll get x to the 1, or merely x, is equal to a base that's being taken to a negative exponent. So we're going to have to use the rules of negative exponents, and that brings in reciprocal. So we're going to have to take that negative 1, so let me put this off to the side. That negative 1 is actually this. And if we reciprocate that, so be it. 1 divided by negative 1 is still a negative 1. But when you reciprocate, that allows you to change that negative 1 to a positive 1. And negative 1 to the first is going to keep that negative 1. So x being equal to negative 1 is one of the solutions. Let me just back up again on this right-hand side. If we reciprocate this base, that will give us the authority to change that negative 1 to a positive 1. So I kind of took that negative 1 and I pulled it off to the side, and I just kind of wrote it over 1 so you could kind of see the fraction that's still equivalent to negative 1. If you invert that and make it 1 over negative 1, 1 over negative 1 is negative 1, but it gives us the right to change that exponent from a negative to a positive, and negative 1 to the first is going to stay negative 1. This one, that's x. Reciprocate 1/2. Turn it upside down, and we'll have 2. Gives us the authority to change that to a 1. It's just simply 2. Those would be the solutions. The set whose members are negative 1 or 2. We would have that. One more for the road. Three x to the 2/3, negative 11x to the 1/3, negative 4 is equal to 0. Already have exponents up there. Constant term, trinomial. If we take the variable part of the middle term and square it, you multiply those exponents and you're going to get that 2/3. So everything fits to make it quadratic. We're going to let u be equal to the variable factor of the middle term, x to the 1/3. Now we'll come over here, bring down that coefficient of 3, put a house, substitute x to the 1/3 in here, to the second. Bring down the negative 11, make a house, x to the 1/3, negative 4 is equal to 0. A u's going there because it says so. A u is going there. 3 u squared, negative 11u, negative 4 is equal to 0. The coefficient of u squared is not 1, so if we need to use the structure in the AC method, the middle term is negative 11u. A times c would be negative 12. One is negative, the other one is positive. Two factors of 12 that when really subtracted from one another would give us 11 would have to be 12 and 1, with 12 carrying the sign of the middle term and the other u going in the other spot. Bring down the 3u squared. Then bring in 9 o'clock, then 3 o'clock, then bring down the negative 4, and that's equal to 0. We'll tuck the front pair and tuck the back pair. The front, take out a 3u, and that's going to leave us with a u minus 4. Take out a positive 1, and that's going to leave us with a u minus 4 is equal to 0. Bring down that common binomial factor of u minus 4. And the other will be the turkey and the gravy right here. The 3u plus 1 is equal to 0. U minus 4 is equal to 0. or 3u plus 1 is equal to 0, u is equal to 4, or 3u will be equal to -1. That would make u equal to a -1/3. Erase some of this up here. U is equal to 4, or u is equal to a -1/3. Now we'll back substitute now. In place of u, x to the 1/3. Or x to the 1/3 is equal to a -1/3. Now what's nice about this one? We have rational exponents. That means radicals are involved. But look at the denominator of the rational exponent. It isn't even. It's odd. And when it's odd, all real number solutions are accepted. So we won't have to worry about doing any check. We don't have to worry about having extraneous solutions. Both of these will be valid. We're going to raise both sides by the power of the index. We're going to raise the left-hand side to the third, and likewise the right-hand side to the third. 3 times 1/3 is 1. So we have x is equal to 4 to the third. It's good. Over here, raise both sides by the power of 3. And we'll get an x is equal to -1/3 to the third, -1/3, -1/3, -1/3, -1/27. And if you want the roster notation, something like this. And he's good looking. And we've completed 8.4. We've taken care of something that is dealing with quadratic equations by using a substitution. We'll get the 8.5 out of the way and it'll be done. Take care of yourself. Bye-bye.